Good morning, good afternoon, and good evening, wherever you might be in this world now. Welcome to my talk, Log4Shell Response Patterns and Learning from Them. Before we start, I just want to put this out, a good attribution. I just want to call this out. This talk is based on a paper that I was a part of. So big thanks to Randy, Michael, Chris, and Dominica for making this happen. Also, big thanks to IT Revolution for creating a platform to do this type of research and promote them. You probably should be able to get to the paper by following that yellow link there. If not, do a Google search on responding to novel security vulnerabilities and IT Revolution. You should be able to get that. The next thing is about me. I'm Tapabrata Pal. Currently, I'm with Fidelity Investments, and I'm one of the vice presidents in enterprise architecture. I'm responsible for DevOps domain architecture and open source program office. Essentially, I'm a developer, open source contributor, and a DevOps enthusiast. I also speak at many conferences, but first time here at QCon. Recently, I have co-authored a book called Investments Unlimited. It is a story about a bank undergoing DevOps transformation and suddenly hit by a series of findings by the regulators. The book is published by IT Revolution and available on all the major book selling sites and stores, so go check it out. Now, let's look at some interesting numbers. So by 2024, 63% of world's running software will be open source software. In AI/ML specifically, more than 70% software is open source. Top 4 OSS ecosystems have seen 73% increase in download. Python library downloads have increased by 90%. And a typical microservice written in Java has more than 98% open source code. Now, if you look at the number, they are quite fascinating. They're encouraging, they're interesting, and scary all at the same time. Interesting is just the numbers, 63, 70, these are all just good, interesting numbers. Encouraging is that these big numbers, just seeing where open source has come to. Now, the scary is, again, those big numbers from an enterprise risk standpoint, which basically means that most of the software that any enterprise operates and manages are out of their hand, out of their control. They're actually written by people outside of their enterprises. However, about 90% of IT leaders see open source as more secure. And there's another argument against this, the bystander effect. Essentially, everyone thinks that someone else is making sure that it is secure. So the perception is that it is more secure, but if everybody thinks like that, then it may not be the reality. In whatever it is, it's just the fact that 90% leaders trusting open source is just huge until this happens. Everything goes in smoke when a little thing called Log4j brings down the whole modern digital infrastructure. And then the next thing to look at is that the timeline of Log4Shell. So I took this screenshot from Aquasec's blog. So a lot of thanks to them. This is one of the nicest timeline representation of Log4j. And this is just for a reference. You can look it up offline, or you have probably already looked at it, or you can take it from the deck. Nothing was officially public until the 9th of December 2021. And then over the next 3 weeks, there were 3 new releases and correspondingly new CVEs against those and more. It was a complete mess. And it kind of continued to the end of December and then bled into next year, January, which is this year, and then February. And maybe it's still continuing, we'll see. So let's start with the response patterns. I'll call them stories. As a part of writing this paper, we interviewed or surveyed a handful number of enterprises across financial, retail, and healthcare companies of various sizes. Now, these companies will remain anonymous forever. The survey is not scientific by any means. Our goal was not to create a scientific survey. We just wanted to get a feel of what the industry and the people in the industry experienced during this fiasco, how they are impacted. I think most companies will fit into one of these stories. And these stories are not like individual enterprises that we pick from our sample. This is kind of collected the whole stories and grouped them in 3 different buckets, and that's how we are presenting. Even though it may sound like I'm talking about one enterprise in all of these, each of these stories, but they're not. Now, I also thought that, about the name of the story, the good, the bad, and the ugly, but I don't think that that's the right way to put it. So we'll do number 1, number 2, and number 3. As you will see that there's nothing bad or ugly about it. It's just about their maturity, these enterprises' maturity. The stories are important here because you'll see why things are like what they are. Now, the question is, what did we actually look at when we built the stories and created these response patterns? Well, these are the things that we looked at. The number 1, the detection, or when someone in a particular enterprise found out about this, and then what did they do? Number 2 is declaration. At what point there's a formal declaration across the enterprise saying that there is a problem. Now, typically this is from a cyber group or information security department or from a CISO's desk, etc. Next is the impact analysis and mitigation. How did these enterprises actually go for impact analysis and mitigation? Mitigation as in stop the bleed. And then the remediation cycles. Now, we call it cycles intentionally because there was not just one single remediation. There are multiple of those there because, as I said, there are multiple versions came along in the period of 3 weeks, roughly 3 weeks. And then the cycles are also some cycles that are generated by the enterprise risk management processes that go after this set of applications first, then the next set, then the third set, etc., etc. And we'll talk about those. The last one is the people. How did the people react? What did they feel? How did they collaborate? How did they communicate with each other? And overall, how did they behave during this period of chaos? So we kind of try to study that. And based on these, we form these different patterns, the 3 patterns, and I'm calling that 3 stories. All right. So with that, let's look at the first news of Log4J vulnerability, the power of social media. Came out at around 6:48 p.m., December 9, 2021. I still remember that time because I was actually reading that when it popped up on my Twitter feed. And I actually called our InfoSec people. But again, I'm not part of the story, so let's not talk about myself. So that's the start of Log4j timeline. With that, let's go to the detection. Forgive me about the time, 12/9/2022 date. That's actually 2021. So on 2021, December 9th, let's talk about the detection. Now, to note that InfoSec was not the first one to know about it. Maybe they knew about it, but they are not the first one. Also note that right from the get-go, there's a clear difference between the 3 with regards to just handling the tweet. Number 1, cyber engineering. Some engineers in the cybersecurity department noticed the tweet and alerted their SCA or software composition analysis platform team immediately. And then other engineers notices that too in the Slack, internal Slack channel. SCA platform team sends inquiry email right then and there to the SCA vendor in that evening itself. Now, number two, similarly, some engineers notice the tweet and sends the link to the team lead, the Twitter link. And the team lead notifies the information security officer, and it stops there. We don't know what happened after that in most of the cases. Number three, on the other hand, there's no activity to report. Nobody knows if anybody have seen that or if they did anything, nothing to track. Now, notice the difference between number one and number two. Both of them are reacting. Their engineers are not waiting for InfoSec's direction. Now, we don't know what the ISOs did after number two. Actually, the team lead in number two enterprise notified the ISO, and we don't know what the ISO did after that. Now, let me now try to represent this progress in terms of some kind of status so that we can visualize it and kind of manually and kind of understand what's going on here. So I would say in this case, number one is on green status on 0 day. Number two is also green. Number three is kind of red because we don't know what happened and nobody knows. Now, with that, let's go to the next stage, which is declaration. Or, in other words, when InfoSec or cyber called it a fire, that we have a problem. On December 10th morning, the SCA vendor confirms 0 day. And engineers at the same time almost start seeing alerts in their GitHub repository. And then the cyber team declares 0 day, informs the senior leadership team, and the mass email go out. This is all in the morning. So I think they are on green on day one. They reacted in a swift manner that put them in the green status. Number two, ISO notifies the ISO who was informed about this on the previous day, notifies the internal red team. Red team discusses with some third-party vendors, and they confirm that it is a 0 day. And then CISO is informed by the midday, and then senior leadership meeting during the late afternoon, they discuss the action plan. Now, they are on yellow because, as you notice, that first of all, that's late in the day that they are actually discussing about the senior leadership team and about action plan. They should have done it early in the morning, I think, as number one. Number three, on the other hand, the red team received daily feed in the morning about their security daily briefing. And then enterprise risk office was notified before noon. And then the risk team actually met with the cyber and various quote-unquote DevOps teams. And the first thing they do is enter the risk in the risk management system. So that's why they're yellow. Now, on the impact analysis and mitigation process, this is about first, try to stop the bleed. Second, where the impact is, which application, which platform, which source code, etc. And then measure the blast radius and find out what the fix should be, and then go about it. Now, number one, before noon on December 10th itself, right after they sent out that mass email, they actually implemented the new firewall rule to stop the hacker to come in. By noon, their impacted repositories were identified by the SCA platform team. So they have a full list of repositories that needed to be looked at, or at least impacted from this Log4j usage. By afternoon, external facing applications start deploying the fix via CI/CD. Now, note that these are all applications that are developed internally. These are not vendor applications, not vendor supplied or vendor hosted applications. Now, overall, I think number one has done a good job. They responded really, really quickly. On the same day, they started deploying the changes to external facing applications. Number two, on the other hand, They implemented the firewall rule at night. Now you may ask, why did they do that at night or wait until the night? I do not know that answer, but probably they're not used to changing production during day, or maybe they needed more time to test it out. I don't know. Number two, however, struggled to create a full impact list. They had to implement custom scripts to detect all Log4j library usage in their source control repositories. So I think they are a little bit behind because they actually took a couple of more extra days to create full impact list, and they really did not have a good one to start with. So all those custom scripts were created. Now, number three, on the other hand, they went to their CMDB system to create a list of Java applications from the CMDB. Now, there are two assumptions to it. One is that they assume that all Java applications are impacted, whether or not they use that particular version of Log4j. And number two is they assume their CMDB system is accurate. Now, the question is, how did the CMDB system know which Java applications there are? It's essentially developers or development teams manually identify their entries, CMDB entries, to have Java programming languages used. Now, based on that CMDB entry list, email sent out to all the application owners. And then project management structure was established to track the progress. So nothing is done yet, nothing is changed. It's just about how to manage the project and getting a list. So I think they are great and on the fourth day. Now, let's look at the remediation cycle, the starting of it. Of course, there are multiple rounds of remediation. Now, one thing I would call out is that in all the enterprises that he spoke to, they all had the notion of internal-facing application versus external-facing application. Any customer, they actually, they consider them as external facing. Any customer facing application is external facing application. Rest are internal facing application. The enterprise, every enterprise seems to have a problem in identifying these applications and actually mapping them with a code repository or set of code repositories or an artifact in their artifact repository, etc. Now, it is more of a problem if you use some kind of shared library or say shared code base all across your applications, across the whole enterprise. And then we also notice that all enterprise have a vulnerability tracking and reporting mechanism that is fully based on these application IDs in their IT service management system, where the applications are marked as internal versus external. They fully rely on that. Now, we may or may not agree with this approach, but this is a common approach across all the big enterprises that we talk to. I think it's a common struggle. Now, back to the comparison. So number one, during December 11th and 12th, they fixed all their external facing applications, and then they started fixing the internal facing application on December 13th. I think they're a little bit yellow on that side, and I think they struggled a bit in finding out these two sets of applications, internal versus external, and spent some cycles there. Number two, on the other hand, they actually reacted to the new vulnerability on 13. Now they are in the middle of fixing for the first one, the second one came in, and then there's a confusion. On December 14, they opened a virtual war room, or war rooms rather, all on Zoom, because people are still remote at that point. 50% of external facing applications fixed their code, and some of them are in production, and most of them are not. Number three, on the other hand, they are manually fixing and semi-manually deploying over the period of December 14th and 16th. They do have incorrect impact analysis data. So basically, they're fixing whatever they can and whatever they know about. And project is, of course, in red status, and we don't disagree with that. So we put a red status on them at this remediation cycle. Now, remediation cycle continues. So number one, they actually, through the period of 13 to 19, they even fixed two new vulnerabilities, two new versions, Log4j 2.16 and 2.15, and then 16. And then two more, that's two more cycles of fixes, all automated, and then, all external facing applications are fixed. Number two, the war room continues through the whole month of December. External facing application fixed multiple times via automated pipeline, or semi-automated pipeline rather. Internal facing applications must be fixed by end of January 2022. So they did actually determine that, with the firewall mitigation and external facing application being fixed, they don't have that much risk with internal facing. They took the approach that, okay, let's give 1 month to the developers to fix all the internal facing applications. Number three, some applications are actually shut down due to fear. This is quite hard to believe, but this is true, that they got so scared that they actually shut down some customer-facing applications so that the customers so that no hacker from outside can come in. And at that time, they basically did not have a clear path inside to fix everything that were really impacted. At this point, I would say number one is green, and then number two is kind of on the 20th day, they are still red because they're not done yet. And number three, who knows, they're red anyway. Aftershock continues. So it's kind of wrapping up stories, but I'll just go through that. Vendors start sending their fixes starting January 2022 for number one. But I think the overall, within 40 days, they fixed everything. I think they're green. For number two, it took double the time, but I think they reached, so that's why they are green. They at least finished it off. Number three, most known applications are fixed. The unknowns are not, of course, fixed. Now, to be honest, as I say that these are, number one and number two, they claim to have fixed everything. But the interesting part, maybe it's because of the number three, is that from Maven Central standpoint, Log4j 2014 and 15 are still getting downloaded as I speak. Now, which enterprises are downloading, why, nobody knows, but they are, which basically tells me that not all Java applications that were impacted by Log4j 2.14 actually got remediated, so they're still there. So maybe, they have custom configurations to take care of that, or they are not fixed. I don't know. I couldn't tell. At this point, if you look at the status, as I said, it's number one green, number two green, and number three is red. Now, let's talk about the effect on people. As you can guess, most of us, the Java developers and people around the Java applications, they want to forget these few weeks and months. Actually, it was the winter vacation that got totally messed up. Everyone saw some level of frustration, burnout, and had to change their winter vacation plan. Number one, the frustration was mostly around these multiple cycles of fix. You fixed it and you thought you were done and you're going packing up for your vacation, and then your boss called you and said that nope, you need to delay a little bit. But overall, few had to delay their vacation for a few days. Overall, no impact on any planned vacation. Everybody who had planned for vacation actually went for vacation happily. Number two, people got burnt out. Most Java developers had to cancel vacation. Many other canceled their vacations around the Java development teams, like management, Scrum Masters, and release engineers, and so on and so forth. The other impact of this was that for most of these enterprises, January and February actually became the vacation months, which basically means that the full year 2022's planning or feature delivery planning got totally messed up because of that. Now, Number three, people really got burnt out, and then their leadership basically said that, okay, this is the time where we should consider DevSecOps as a formal kickoff of their DevOps transformation, if you will. We don't know. We did not keep track as to what happened after that. Now, that's the story. So we wrapped up the story of the patterns, response patterns. Now let's go through the learnings. Now, the learnings have two sides to it. One is, let's understand first the key characteristics of these three groups that we just talked about. And then from those characteristics, we will try to form the key takeaways. Is that fair? All right. Let's look at the characteristics for the good one, or the number one. They had software composition analysis tool integrated with all of their code repository. So every pull request got scanned, and if any vulnerabilities were detected in that repository, they got feedback through their GitHub issues, etc. They had complete software bill of material for all repositories. And these are not like, I'm not talking about SPDX or CycloneDX form of SBOM. These are just pure, simple dependency list and their metadata for every repository. They also had fully automated CI/CD pipeline. And as we noticed here, that unless a team had a fully automated CI/CD pipeline, manually fixing and deploying 3 changes in a row within 2 weeks is not easy for all across the enterprise. They had mature release engineering and change management process that are integrated with their CI/CD pipeline that help them actually to carry out this massive amount of changes within a short time frame across the whole enterprise. They also had good engineering culture collaboration. As you have seen during the declaration on detection phases, the developers were empowered to make decisions by themselves. As I mentioned during the declaration phase, the developers knew that it is coming and it is bad and it's going to be bad. They did not actually wait for the mass email that came out from the CISO's days. They actually were trying to fix right from the get-go. I mean, they noticed it first and then they took it up of themselves to fix that thing. They did not wait for anyone. So that's called developers empowerment. Also the culture that the developers can make a decision by themselves whether to fix it or not, and actually not wait for in InfoSec. And then, of course, this resulted in good DevOps practices, good automation all the way through. Most of these applications in these enterprises were they decided on cloud, so no issue there. On the other hand, the not so good on number two, they had SCA coverage, but limited. And it was not shifted left. It was like, they scan, or most of these enterprises, and for most of these applications, they scan right before the release, which was kind of too late. They're on the right side of the process, not on the left side. They did not have the full insight into the software bill of materials or simple dependency tree. They had some. They had semi-automated CI/CD pipeline, which basically means complete CI automation, but not so much on the CD side or the deployment side. They did have good change management process. So please make sure that, what I'm saying is that these enterprises are actually very mature enterprises. It's just that got hit with Log4J in a bad way. They do have good team collaboration. As you have noticed, the developers in the cyber engineer saw that, then they, immediately the engineer passed it on to the team's lead, who passed it on to the ISO. So that's a good communication mechanism and team collaboration. But they did have a bit of hero culture, because since they did not have full SCA coverage, basically some of their developers stood up and said that we are going to write a script and they're going to scrape the whole heck out of GitHub, their internal GitHub, and report out on all the repositories that had a notion of log4j in their dependency file or pom.xml or Gradle file. So with that, they struggle quite a bit, if I may. Now let's talk about number three. They did not have anything. No SCA, no tooling, and then, as I said, classic CMDB-driven risk management. So it's basically look at your CMDB, look at all the Java application, just inform the owner, and it's all of them their responsibility. And sorry, and we are just going to track from risk management perspective. They did have DevOps teams, but they're not so effective. They're just called DevOps teams. Probably they are just renamed Ops team and not so much DevOps. Of course, that as you can tell, that they have weak engineering culture and silos. So basically, even if somebody saw something, they would not have told cyber, because they don't know that they're supposed to do that, or they're empowered to do that, or anybody would entertain anybody's communication that way. So we don't know. So, let's not make any judgment call, but I think overall what we found is that they had weak engineering culture across the enterprise. Now, the key takeaways from these, what I would like to do, take a step back and try to answer these four questions. Number one, what are the different types of open source software? How do you bring them in an enterprise? And then once you bring them in, how should we keep track of their usages? And then the last question is, what will we do when the next Log4Shell happens? Are you going to see the same struggle, or things are going to improve? So let's go through one by one. The first thing, open source come in many forms. Some are standalone executables, some are development tools, utilities, some are dependencies, and that's the Log4j. These are the things that get downloaded from artifact repositories and gets packaged with the actual application. Even source code that gets downloaded from github.com, and then they get into the internal source code repositories or source code management system. And they come in different formats too, like jar, tar, zip, Docker image, and etc. So these are the different forms of open source. Log4j is just the third bullet point. They fall into the dependencies. We don't actually, most of the time, we don't look at the other types. They also come in via many paths. First, developers could directly download from public sites. Some enterprises have restrictions around that, but that creates a lot of friction between the proxy team and the developer or the engineering team. So some enterprises chose not to stop that, which basically means developers can download any open source from public sites. Now, pipelines can download build dependencies from their continuous integration pipeline integration, but most of these build dependencies are in all the enterprises that we saw in number one and number two group. They actually downloaded from an internal artifact repository like Artifactory or Nexus. Now, for standalone software and tools and utilities, many enterprises have internal software download site. And then production systems sometimes directly download from public site, which is kind of ouch. It's pretty risky, but that happens. And then open source code gets into internal source code. We just talked about that. So, we don't usually pay attention to all of these paths. We just think about the CI pipeline, downloading Log4j and all that, but the other risks are already there. So all of these are known, right? If you narrow it down, you could write down more actually. But then what are the risks involved with that? So we need to kind of do the risk mitigation or risk analysis on that anyway. But to track how they're used, or if you want to manage these usage, the first need to know what to manage. Now, what to manage comes from what we have, right? So first thing is, for all applications, whether they're internally developed application or vendor software or standalone another open source software, we need to gather all of them and their bill of materials and store them in a single SBOM repository. Now, this could be, as I said, internally developed application, runtime components, middleware, databases, tools, utilities, anything that is used in the whole enterprise. And then we need to continuously monitor that software bill of material. Because without the continuous monitoring of the software bill of material, it's hard to tell whether there is a problem or not, or when there is a problem. Now, with continuous ISBA monitoring, and we need to also establish a process to assess the impact. If that continuous monitoring detects something and creates an alert, what is going to happen across the enterprise? What is the process of impact and analyzing that impact? Who is going to be in charge of that? All this process needs to be documented, and then establish process to declare vulnerability. At which point, who is going to declare that we have a big problem, and what is the scope of the problem? Who is going to get notified, and how? All this need to be written down so that we do not have to manufacture these every time there's a Log4Shell. Without these, we will run into communication problem, communication breakdown, or it will unnecessarily cause a lot of pain or friction to a lot of folks that we do not want. In terms of mitigation and remediation, we need to decide whether we can mitigate only, or we need to remediate or fix the root cause as well. In some cases, just mitigation is good enough. Next, do we need to manually remediate, or we need to automate that? It depends upon what it is, how big it is, and whether we have the other things to support us in this automated mitigation process. Prioritization is another big thing, because, as I said, external versus internal, or what kind of open source it is, the prioritization will depend upon that and its risk profile. So that prioritization itself is can be a complex one and be time-consuming one too. And then deploying the remediation, automation, and that's the only way to go. The last thing, probably the most important tool that we have, is the organizational culture. I'm convinced that the Log4Shell response within an enterprise talks a lot about the enterprise's DevOps and DevSecOps technical maturity and culture, the engineering culture, leadership style, organizational structure, how people react and collaborate, and their business and their overall business mindset. Do they have blameless culture within the organization? That is also something that comes out of these kind of events. We often use the term shift left security. We most likely mean that having some tools in our delivery pipeline or code will solve the problem, but it is more than that. We need to make sure we empower the developers to make the right decisions while interacting with these tools. Each of these tools will generate more work for the developers. How do we want the developers to prioritize these security issues over feature delivery? Can they decide? Are they empowered to decide themselves? Lastly, practicing chaos. Just like all other chaos testing, we need to start thinking about practicing CVE testing, chaos testing. Practice makes us better. Otherwise, every time there is a Log4Shell, we'll suffer, spend months chasing these, and we'll have demotivated associates, and that will not be good. Because the question is not if, but the question is, when will there be another Log4Shell? So thank you very much for listening to me. I'll just see if there are any questions, and I very much like to thank Econ for giving me this opportunity.
Hey there.
Hello.
Good afternoon, everybody. So we'll just jump right into questions, and we just got one in the chat from Ryan. He asked, were there any questions in your survey asked about the completeness of indicators of compromise analysis?
Yes, partially, but not a whole lot. So we just wanted to know the reaction more than the action. So yes, we did ask about how do you make sure everything is covered. We did ask about whether you completely mitigated or remediated or both. But that was not our intent of the questionnaire.
So, as a result of all the research that you've done, what would you prioritize first to prepare for future vulnerabilities, and why?
So the first thing that comes to my mind, and I kind of had some of the slides there. First, we have to know what we have, and the problem is that we don't know what we have. And that is because, first of all, we don't have the tools, and neither we have a collective process of identifying the risks where we need to kind of focus on. As I said, there are many forms of open source that we don't have control over, and there are many ways that we can get them in our environment, but we only focus on the CI/CD part, and that too in a limited way. So we have a lot more way to go. So to answer your question directly, the first thing is know what you have first before you start anywhere else.
Awesome. And are you aware of any good like open source tools or products for helping with that, managing your inventory and doing that impact analysis?
There are there are some good commercial tools. Also, I'm not going to name any of them here. There are some good tools, and in fact, on GitHub itself, you have dependable, easily available, and few other tools. So, yes, start using that. To be honest, I think we do have some good tools available right away. You should just pick one and go.
Awesome. Thank you. Um, so once you know what you have that you need to deploy and you're able to identify it, I know that you talked about like automation for delivery and enabling automated deployment and release. What technical foundations do you think are really important to enable that?
So in general, to enable CD continuous delivery in a nice fashion, I think the foundation block is the architecture of the thing. Because if it is a monolithic architecture, and we all know that if it is a big monolithic application, yes, we can get to some automated build and automated deployment, but not so much on the continuous integration in the classic sense and in the continuous delivery in the classic sense. There can be more automation, but that's about it. To achieve full CI and CD, and I'm talking about continuous delivery, not continuous deployment, we actually need to pay attention to what our application architecture looks like, because some architecture will allow you to do that, some architecture will not allow you to do that, period.
So, what are some of the patterns that you would recommend to allow you to do that?
So one is that, for good CI/CD, it's decoupling is number one, so that I can decouple my application with respect to anything else, so that I can independently deploy my changes and I don't have to depend upon anything else or anybody else around me. That's number one. And number two is, as soon as I do that, then the size of my thing comes into picture. And the ideal case is, of course, the minimal size, which is kind of the microservice. I'm going towards that term without using that term. So essentially, keep your sizes low, be lean and agile, and deliver as fast as possible without impacting anybody else.
Awesome. So, one of the things that I love that you brought up in your talk was the idea of practicing chaos. In this context, what kind of ideas do you have for like how that would look?
Yeah, once we have the knowledge about, let's say we develop the tool, kind of follow up from your first question. If we had the tools develop, and we have an inventory of things that we have in terms of open source, just like chaos, let's find out how many different ways we can actually generate a problem, such as declare a dummy CVE as 0-day vulnerability and 10, score 10, and see what happens in the enterprise. So those kind of things, so that you can kind of formulate few scenarios like that, and see what happens. And you can do that in multiple levels. You can do it at the level where it's just developer tools on somebody's laptop, versus a library like Log4j that is used everywhere almost. So yeah, there are various levels that you can do that.
That's awesome. I love that idea because I think, with these things that we don't practice very often, that could give us a muscle to improve and measure like our response over time. So
Right.
that's awesome. All right. Are there any other questions in the chat? If not, I think we're wrapping up on time. Yep. So if you do think of something that you haven't brought up to this point, feel free to find us in the Track Architecting Change Slack channel, and we will look forward to seeing you there. Thank you, Topo.
All right. Thank you.